Show which types of symmetry are present in each equation. So you can do this algebraically or you can do this geometrically. I think geometrically is a lot easier. We're going to graph the equations and look for the symmetry. So let's use Desmos. You can get there through my website. If you go to the math sites and find Desmos. Okay, I think Desmos is probably the best graphing site I've ever seen. So let's use that. We want to graph x equals absolute value of y. Whoops. X equals absolute value of y. Okay. So we can see it's a V shape, but it's sideways, right? We can see vertical line test. It's not a function. We can see all kinds of stuff. So a sideways V shape. I'm going to go ahead and sketch that real quick. A sideways V shape. Okay. So you can just see what type of symmetry it is. It folds over the x-axis onto itself. That's x-axis symmetry. Symmetry is when you can fold it over on itself. Okay. It folds over the x-axis. That's x-axis symmetry. Okay. So the next one, let's go back to Desmos. And this one was y equals absolute value of x minus 3. Okay, and it's another V shape. And we can see the vertex is down at 0, negative 3. It looks like it folds over the y-axis onto itself. So this one appears to have y-axis symmetry. A quick sketch of this would look something like this. That has y-axis symmetry. Now, again, I could probably make you do the algebraic method. I think there are some questions on the homework that say do this without graphing. But I'm going to just ignore that and I'm going to say just go ahead and graph it. I think that's going to be easier for you and I know it's going to be easier for you a lot faster. All right, so the next one, 2x minus y equals 6. Oops. Okay, so it's a line. It crosses through negative 6 down here and positive 3. So quick sketch. Something like that. It doesn't seem to have any symmetry, okay? If it, take a point right here. If it had y-axis symmetry, there should be a point reflected over there. If it had x-axis symmetry, there would be a point reflected over here. It doesn't have either of those, okay? It doesn't have either of those. And I believe I missed a statement on the last one. A function possessing any two types of symmetry must also possess the third. But we can see that it doesn't really have any of them. I guess when I think of origin, sometimes I'll think about this point would do like both of them. If you went over and over, it would be right there, okay? But that doesn't have any of those, so you can say no symmetry. Moving on. Does anybody know what shape this shape is on part D? That's good. Say it. What is it? Good. That's a circle. Okay, so we can type that in. X caret 2 plus y caret 2 equals 25. Okay, that's a circle, and you can see specifically that circle has a radius of 5. All right, so circle, let's see what kind of symmetry that is. So if you think about symmetry, some point over here, if it has x-axis symmetry, is going to map onto this point over here. Oh, my pen won't work. Okay, that appears to have x-axis symmetry. And that same starting point would map over onto this. That appears to have y-axis symmetry. And then that statement above says if it has one, it has both. If it has two, it has all three. If it has two forms of symmetry, it has all three forms of symmetry. But I think of it as you go both like this, okay? If it goes over and over, it's still on the circle. So it has all three. This has x-axis, y-axis, and origin symmetry. Okay. Next one. Does anybody know what shape part E is before we do it? Negative 2x cubed? Maybe you do. Okay. Disco function. Disco function. So quick sketch. Notice it's decreasing. Looks like this. So you take a point, it doesn't appear to have y-axis symmetry, and it doesn't appear to have x-axis symmetry either, okay? But what it does do is if you take this point right here and you go over and over, it does appear to have origin symmetry, okay? If you do a both, that's kind of how I look at it. Another way of looking at it is if you could do this, okay, so watch carefully. If you could take this half and like spin it around 180 degrees. That's another way of thinking about it. Okay, rotating it around the origin. That's probably a better way of thinking about it, but this has origin symmetry. Or symmetry with respect to the origin. Next one, negative 2x squared. If you know what that looks like without Desmos, then great. Some of you probably do. Negative 2x squared is an upside down parabola. Appears to have which type of symmetry? Y-axis. You fold it over the y-axis. That's y-axis symmetry. Okay, y-axis symmetry. Even and odd. Okay, even functions have this property. F of opposite x equals f of x. What that means is if you plug in 2 or you plug in negative 2, you're going to get the exact same thing. If you plug in 5, you plug in negative 5, you're going to get the exact same thing. Okay? All of the powers are even. It's got symmetry with respect to the y-axis. And the end behavior is the same, like up and up, or down and down. Okay, notice I left a gap in the middle because we don't necessarily know what happens in the middle or care. I don't care what happens in the middle. I'm talking about what happens on the end. The arms either both go up or the arms both go down. Odd functions has the property that f opposite of x equals negative f of x. And what that means is if you plug in 2 or you plug in negative 2, your results are going to be the opposite. Okay? If you plug in 2 and get negative 17, then you plug in the opposite number, negative 2, you're going to get the opposite number, positive 17. Okay? All powers are odd. And the symmetry with respect to the x-axis and the end behavior is opposite. So one of them would be down and the other one would be up. Or one of them would be up and the other is down. That's your end behavior. So talk about the graph. So if we look at this graph right here, is that graph odd or even? That's even because they're both the same. They're both down. If it's down and down, that's even. Okay. But a minute ago we did like this one. This one would be odd because one of them's up and one of them's down. You're talking about the ends of the graph. The first one's up, the second one's down. That's odd. Okay, determine whether each function is even, odd, or neither. Well, this is pretty easy because all you do is look at the powers. If all the powers are odd, this is an odd function. So 5, 3, and 1. This one, notice 3 is like 3x to the 0 power. So your powers, your exponents there are 2 and 0. That's even. And then this next one, x squared, x to the first, and x to the 0. This is neither because you have some even and some odd powers. Number 3, use the parent and transformations to draw a quick sketch of the graph. So this is where we have to go back, and I told you to memorize those shapes, okay? The parent function is an x squared, and so you're supposed to have memorized that this is a parabola. You know that's a parabola, okay? So that's when they say use the parent, they're saying, I know this is a parabola, okay? And the transformations to draw a quick sketch. So transformations means, what does this make the function do? Up, down, left, right. Do you remember? That's left 4. So you take the parabola and shift left 4. So a quick sketch of that would look like this. Now we could do more details if we wanted to, but I'm drawing a quick sketch. That's all I really need to do, okay? Sometimes you just need a quick idea of what it looks like, and you don't have to be super detailed. Is that vertex touching the axis? Make sure that vertex is touching the axis right there. It should be at the point -4, 0. Part B, identifying the parent. You can see that that's another x squared, so you should be able to tell that that's another parabola. Knowing that that's an x squared graph, I know that that's a parabola, but we can do some things with the transformations. Like this is a flip. That negative sign flips it upside down. And this -1 says we're going to go right 1. And this +4 says we're going to go up 4. So it's a flip. It's going right 1. It's going up 4. So if I was going to draw a quick sketch, I would know right 1 and up 4 is the vertex of that parabola. Right 1 and up 4 is the vertex of that parabola. And then, oh yeah, by the way, it's an upside down one because it's flipped. That's a quick sketch. I don't have to be super accurate. I just need a quick idea of what it looks like, and that's it. Part C, the parent function looks like what? Is that a parabola? The parent function is absolute value of x, which we know is a v-shape, correct? I know that's a v-shape. I know that's a v-shape. So the negative flips it. The 2 stretches it. And the +3, the x +3 says left 3. So it's a V shape. It's flipped and stretched and moved to the left 3. So that means I know the vertex of that V shape is at -3, 0. And I'm going to have a kind of steep V shape that's upside down. Flipped, stretched, and left 3. I could do some tick marks on the y-axis and be a little bit more accurate, but I don't know that I care to. Next one, part D. You're supposed to recognize the square root of x, and you're supposed to know what shape that is. You should have memorized that a couple of lessons ago. Maybe you did, maybe you didn't. But a square root shape, I call it an angry eyebrow. It kind of looks like an eyebrow shape to me. It also kind of sort of almost reminds me of the shape of the square root, if that helps. Okay? The radical symbol kind of almost has that shape, I suppose. Of course, you don't have that extra little tail on it, but anyway, it's that shape. So we need to think about this as being a stretch. Now, it's a stretch by a factor of 1/2, so you might think of that as like a squish. Okay, it's like stretching it by 1/2. If I'm a 6 foot tall person stretched by 1/2, now I'm a 3 foot tall person. Okay, so it's a, I don't know if you want to call it a squish or what. That x plus 2 means left 2, and that minus 3 means down 3. So it's the eyebrow shape, and it's stretched by 1/2, and it's left 2, and it's down 3. So left 2 and down 3 is where the starting point of that eyebrow is. Okay. It's hard to think about a stretch of 1/2 on a square root shape because you're not real comfortable probably with that shape, but it's going to look something like this. Okay. And that's probably good enough for now.